Okay, so first one that was considered kind of a hard question was number two. So this one again was one of those questions where you really had to pick it apart. We're talking about points A and D. So here's A and here's D, and I can kind of ignore everywhere else. And we're going in a circle this way. Now we know that in order to go in a circle, we have a net force that points in. We have, oh, I got my stupid nails on still. Sorry. We have a net force that points in towards the center. Now, what we need to know about that net force is it's constant in magnitude if the velocity of the object is not changing and the radius is not changing. So that force has to stay the same. Even though it's technically changing directions, it's also technically not. It still points to the center. That is a direction that's constant, pointing to the center. So those two F nets are going to be the same. So this is a person of weight FG sits upright on a seat in one of the cars. As the seat passes point A, the seat exerts. Okay, so there's Fn at point A. So what we should have done then is that if I have a little FBD here at point A, now the FBD is actually the same no matter what, technically, at least for the direction of the forces. You have Fg pointing down, but the normal force is what the seat is exerting upwards. So here's Fn. But again, what we know about Fn is that it equals 0.8 Fg. So I can write F net equals, well, because at point A, I'm pointing down. My F net points down, right? What that means is based on my FBD, at point A, Fg has to be bigger. If the net force is pointing down into the center, Fg has to be bigger. Now again, it's going to be minus Fm, but that's 0.8 Fg. So there is my FBD at point A, and my FBD at point D is going to be the same. FG still points downwards, and Fn still points upwards. The difference is my net force now points up, because I'm still pointing into the center, right? So because I'm pointing into the center, my F net there, now Fn is going to be bigger. Now notice that's what they're asking for. It says, what is the normal force exerted on the rider when passing point D? And that's the point we're looking at. So I'm just going to put Fn. The normal force is going to have to change. And we talk about this in this class. If Fn is now bigger than Fg, well, it can't be 0.8 Fg anymore, right? So minus Fg. And in fact, if you were looking at your answers, it couldn't be A or B based on our FBD. Again, because the F net points up, that means that Fn has to be bigger because it points up. Oh, well, and actually, if Fn has to be bigger, you can actually get to your answer right away. There's a way we can finagle this to get to 1.2 Fg. But if you notice your answers, again, sometimes, guys, it's multiple choice tests. 1 Fg cannot be correct either, because that means it's the same as gravity, and it's not. It has to be bigger if I have a net force pointing up. So 1.2 is your answer because that's the only one that's actually bigger than Fg. Again, at the top it was less than Fg, at the bottom it has to be bigger.